Good afternoon, students. So today we continue lecture part of course Medical Informatics with Biostatistics, and I will try to present for you fourth lecture about some introduction basics of statistical data analysis, which is used as background for evidence-based medicine. Okay, let's show for you my presentation for a second. Hope you hear me fine. Okay. So not sure if it will be possible today to pass through all questions in this lecture, because we have some significant volume, but at least a fast pair has to be done. So first of all, such as we have to make some emphasis of usage spreadsheet application for making some statistical analysis. I will try to quickly pass through a question which is related to using of spreadsheet for symmetrical scientific calculation, and then we need to move into statistical analysis, special hypothesis testing. And probably next time I will continue on correlation, regression analysis, management task solving, and those points. So let's move into fast question, and as we decide to use spreadsheet software, so question is to evaluate structure of equation calculation in spreadsheet application, and what is function in the arguments as significant and very helpful tool on the spreadsheet, and equation result which is related to could help us in certain function easily. Here is actually, I think everybody is already proficient what is spreadsheet application dedicated to create electronic tables and present data in tabular format. And what is the major purpose of spreadsheet? For sure, it's make calculation. Because we can make presentation of tabular data with Microsoft Word tables or Google Docs tables, etc., but major purpose of spreadsheet is usage of calculation. And here is given example of typical equation. Like two example, we have very simple mathematical equation above and a little bit more complex with usage of function below. And here is given important points like start symbol with equals and usage of reference. So you have to point to data where you to cells where your data are available, and also have to use function with proper list of arguments. What is important to admit that, as you can see, functions could be translated into local languages. So if you have installed localized spreadsheet version, might happen that part of your function, or almost all, will have local names. Also, instead of columns labels, very often use their numbers in recent times, so it could be covered R1C1 style. And here is another little bit representation of array function, where you for the first time introduce a range or arrays as arguments for function. So in compared to previous time, we have function name, and here is explained part of arguments. In this case, this function expected had to be 2 arguments provided, and each one of these arguments has to be an array or set. In case of array, we have to use delimiter by colon, and it will be all intermediate cells involved into analysis. In case of set, we use comma. It's seconds, minutes later on this. And here is we have another example with usage of more arguments in logical function, and so on. And how we can manage the spreadsheet application when we are entering equation. And one more type of calculation in Excel, it's usage of so-called array function. So in this particular case, we use array function, which is introduced by curly brackets. And in fact, it's multiply each one of the h1 to to A1 to H1 cells by specific constant from given array. So A1 multiplied by 1, B1 by 2, and so on up to H1 by 8. So here is exact how it could be manually entered or automated way. So keep in mind that's very useful things if you have something specific to manage with tabular data with matrix or array operation to do. As of arguments, I can talk about we could have constants like exact value or text number or text value, usually reference to cell. It's conventional arguments, which could be relative when we just mark row, column and cell, column label row number, or column number and row number in R1 C1 notation. Or also we have things which allow for us to create absolute reference for specific cell when we introduce $sign before each one of this part of address, or only for specific column or row. In this case, it will be not automatically update when we copy paste or use autofill tool for calculation. And as I already mentioned, we could use arrays and set as our arguments. With colon delimiter, an array had been created, and we have to only denote start, left, top, and right bottom cell of array, like this case. In case of a semicolon, we create list. And in fact, with semicolon, we can even combine multiply arrays into one. So here it will be like given structure. Also, it slightly depends about local settings of spreadsheet. So semicolon also might have usage as function argument delimiter. So here is as for me have to be obvious, and for sure there is two major way to insert a creation in Excel. We just type in, enter it into free cells that we need with entering function name, and we have to study arguments by Excel documentation, Excel or any as spreadsheet documentation, and so we have to pass through which one arguments provide useful value. Other way, it's wizard, which is available for Excel spreadsheet or a few other spreadsheet application, which starts from this character fx and give for us ability to pick arguments for function in interactive mode. So here is we have how we can manage with this, choose category, search for function, and then interactively provide arguments. So for beginners, it's fine way, but as the effective way, it's only working directly inside cell. So here is a like also for me all minimal necessary techniques that you must know before we move into statistical analysis, like other any kind of analysis with spreadsheet, because all they are based on top of usage of various calculation. And you have to be aware and proficient how to manage with calculation. So now let's move into closely to our objective for statistical calculation in spreadsheet and consider to first of all, some background question, calculation of descriptive statistic, and then move into hypothesis testing approach, and with help and consider special tool like data analysis and on. So let's move in. First of all, we have to remember for ourselves, we have to refresh ourselves what statistic itself has seen as branch of mathematics which deals with collection, organization, analysis, interpretation, and presentation of data. And in case of application of medicine, medical statistics deals with application statistics to medical, so in medical tasks, scientific tasks in medicine especially, as well as useful in health science, including epidemiology, public health, forensic medicine, clinical research, and so on. And medical statistics have been recognized as branch of statistical science fields for decades. So they are subfields, but it's also independent scientific area. And when we talk about statistics, we have very lot of time we refer to probability of something happens. So probability, it's like measure of the likelihood that some kind of event will occur or not, and studied under probability theory, which is in fact also independent scientific area. So in fact, with probability we can decide our chance to win lottery, toss coins, and so on. In fact, in scientific case, it's we are given a model and we want to predict data. But in statistics, especially medical statistics, as scientific area works in another direction, because every time we are supplied with data and we want to predict model or find general rules or get proof that it's not just random things, but it's consequence of some significant event or changes. Anyway, statistics, medical statistics significantly depend on probability theory and use probability distribution theory, and those two scientific areas very closely tied together. Okay, as I already said, we can also define statistics in a simple way. It's measure and assessment of samples or population abstract characteristics. And here is I sign term abstract characteristics. And here is in this definition given word sample, but in fact we can not only measure sample depending to amount of data, depending of coverage of our experiment, we could deal with population data. And in modern time, with help of our technical achievements, we can deal with population data which contain not only very specific population, but even whole world data and so on. So it's become possible. So with statistics, we measure sample characteristics or population characteristics for data if we have ability to measure data for whole population. And all those characteristics are abstract. And again, it's major reason why do we have capability to use statistical analysis for different scientific area. Why it's applicable, for example, in engineering, in social science, and in medicine for sure. Medicine, pharmacy, dentistry, and other area. So because as our measures are abstract characteristics like descriptive statistics, for example, and later we can analyze those values and made some decision, made suggestion in form of hypothesis, and made assessment of how these hypotheses are true or false. But only for researchers it depends to explanation, a relationship between these abstract characteristics to real world problem. Okay, so by this time I defined or update your own population and sample, and in fact also we measure some data, no matter if it represent population or sample, it's turned into variable characteristics that can form different values from one observation to another. And usually we deal with independent and dependent variable or response variable. So as independent measures can take on different values which are subject to manipulation by research. For example, in simplest case, we can define, for example, time range for observation. In this case, time will be our independent variable. And those of characteristics, those with our parameters that we observe and measure during our experiment, but we can't control them, we just observe what do we get, it will be for sure a response or dependent variable. And let's again update yourself on variable types, which could divide into two large group, categorical and quantitative. Categorical in turn can be considered as binary nominal ordinal, where quantity is seen as discrete and continuous. So because depending on what kind of data do you have, It's very often it's critically depend what kind of analysis it's allowed to be used, or what kind of analysis give for you some meaningful information for this case. Let's move on. So like the difference binary from nominal give difference by categories, ordinal give add some extra matters, and numerical and continuous variable, discrete continuous variables, just difference that's either numerical or interrupted. But in fact, every time we deal practically with discrete, once we want to make some analysis, we should fix some value and it's become numerical and discrete. Okay, so categorical or quantitative variables, which could be seen as treatment group, exposure diseases, status. They could be seen as dichotomous or binary, which could two levels, D-drive, treatment placebo, yes, no, exposed, and so on. So you can do nothing, only just admit that's value equal or does not equal to given set. With nominal variables, we have order categories, but order does not matter. It's like a patient blood type, Marshall status, but for ordinal variables, we have order matters, and it's like, sorry, forget, or I almost forget about this. It's a staging breast cancer, birth order, and letter grades, or it's exactly what is your numerical grades given for you by me and as a teacher. In fact, despite we use numerical value, by their meanings, by their features, they belong to ordinal variables. They are categorical variables, and they represent ordinal variables. So in this case, no matter is it talk about letter grades ABC, like your rating, final rating, or numerical grades from 1 to 12. So all this is ordinal variables. And here is actually a reason why rating is correct approach to get some to represent to the success in course, in contrast to the only calculation of averages, which is more common, and even me do this because we have such university order anyway. But finally you obtain this letter grades and rating, which is actually real representation or real success. Okay, in quantitative variables, it's the numerical, which could be arithmetically manipulated, that's like various counts, times, and discrete numbers, limited set of distinct values such as whole numbers, which is like number of not only AIDS, it's like not modern time. In this we talk about COVID cases, number of vaccinated peoples in specific country for time interval and so on. So just emphasis change it to in other diseases. And continuous can take any number within a defined range. So here is we have like heart rate, for example, ECG signal, but when we make recording, we turn it into discrete value. We recorded some fixed discrete value and we provide some quantification for continuous variables. So in fact, they are almost imaginary because practically we work only with discrete value. Okay, so now let's move into descriptive statistics, which give for us that essential characteristics which describe our sample population data set. So major aim of usage of descriptive statistics is to replace large data set, sometimes very huge data set with fairer numerical value, which give for us exactly the same information for our analysis like whole data set. And our benefits, we can avoid to manage like 100,000 of records of data, and we replace it with maybe, for example, dozens of value which give for us exactly the same information. So here is, let's find things that's like not belong to me, this sentence, but it just copy paste it. Yes, I also did it. Every time use common sense, because as I already said, all statistical descriptive characteristics, they are abstract. So if you have numerical assessments, numerical recordings, you have recorded some data from your experiments, you every time have ability to calculate descriptive statistics. But you only think, you have to think about is it response will make sense. Same way situations that for humans we are extremely likely to see visual data, and for us it's very natural to see graphs, to see graphical representation of data. That's true, and we have even some specific statistical charts to represent it. Okay, for manual data analysis, usage of chart is extremely important, for sure. Okay, let's move into conventional chart, which could be helpful with statistical analysis. In case if we have categorical data, nominal, ordinal, very useful, it will be line and bar chart. So I assign at this point, so both this line and bar chart expect that independent variable has categorical data type. And it's a very common mistake when users try to visualize, try to use linear chart to visualize continuous data, to visualize like digitize a DCG, blood pressure, something. For sure it shows something. For sure sometimes it it looks very, very similar to be correct. But we have scientific issue. Independent variable for bar chart must be categorical data type. And if your data not fit in these demands, actually you must not use bar chart nor linear chart. As for continuous, fine idea is to use stem and leaf plot, box plot, and histogram. So there is I sign that all these things it's statistical chart. And just to visualize data, it's very useful things to use scatter plot. So here is when for categorical data bar chart play role of frequency plot, so it's not yet for continuous. This way we have to use box plot, histogram. Typically histogram will show for you frequency plot. But if you want just to see data itself, okay, scatter with continuous or discrete variable, because if you have digitized data, if you turn it to computer, so it's already turned from continuous to discrete. Scatter plot is fine idea. Later I will show some example for this, and here is we will have start from categorical data. And here is example how we have shock index, where index from 1 to 10 it's shock index level, and here is we have number of patients that suffer from this shock index for some specific circumstances, and here is exactly what do we have with categorical data set. So it's parallel frequency plot. And for sure, it's become pretty obviously of these data, and we have some numerical data. Relatively old, but sometimes very fine things to visualize statistical data set. It's used stem and leaf plot, but it's useful only if we have small data set. It's does not working properly for large data set. It's hard to draw it. And here is we have only leading digit as stem and trailing as leaves, and it's like we have such a configuration here for given data set. For sure, it's only in same range working. And most common or like replacement of bar chart for continuous data, it's histogram. it's histogram. So that same role bar chart plays for categorical data, same role histogram plays for continuous or discrete data. Rho assess probability distribution of given variable by describe frequency of observation according to time range and values. Here is we have like reals per minute. It's no matter what is kind of reals, is it we talk about planes arrivals to airports or like new patient arrives to emergency department in case in time of COVID pandemic. Okay, that's will be almost exactly the same things. And here as well, we will have like independent variables this time. So we to build histogram, we have to split this interval, this variable into some interval measures, like we can make this time measure per minute, per second, per hour, per quarter of hour, like not critical there, we have like per minute. And we just count of that even happens, like a real happens. And so here is we plot these things manually or automatically. Most time we do it automatically right now. So to manage with descriptive statistics assessments, there is number of characteristics which could be split into at least 4 groups: central tendency, variation, quartiles, and shape. And let me consider few of these characteristics. So let's start with so when they are applicable first, if we talk about interval level data, measures of central tendency and variation in common statistics. So central tendency describes areas of data with single attribute. Measure of variation describe how widely data deviate from this single attribute or vary. So mean central tendency, we are looking for some central point, central value within our data set, and variation gives us information how specific, how in general our other data deviate from this central value. And various standardized scored combine both central tendency and variation to single descriptor that's comparable across different sample differentiation units of measures. So it sounds complicated, but in fact we are talking about, for example, providing together mean and its error, variance and standard deviation. So here is that things with or mean and standard deviation. So this pair give for us essential information, just like instead of having all my data, when I will see mean and mean error or mean and standard deviation, so it will tell me a lot about what kind of data I have to deal. And if you talk about nominal or ordinal data, proportional percentage, it's a common method to describe frequencies as they compare to a total. So which part of students got negative marks, that it's exactly which proportion of students got negative mark, or which proportion of students provide highest result. So that's a mark in final grade. And okay, sorry, let me back. There is a few common definition of what is mean, median, mode, and how to calculate. So for mean we have or arithmetical average, we have mathematical formula. Median and mode, it's only could be selected manually from our data set. And how it would be seen on on real small data set when we have age as variable or x, and we have each one could be seen as xy or score, each score with number or size, sample size n equals 7. So how we can got mean manually. Okay, why we need that extra, like median, mode, why only mean not enough? simplest reason because each one has own weakness. And for example, mean could be very easy affected by outliers. And here is exact example when we have data set, two data set actually, it's repeated twice, two data set with same size of file, and just one value is different in that data set at the right side for me. So we have outliers when at left side our data is sequence, and in the right side we have one extra value 10 instead of 5. So as you can see, mean different, mean immediately affected by outlines. In contrast, median not affected by outlines. And when we only compare both this value, we can talk about symmetrical and symmetrical distribution we have, and about presence of deviation. So very common term that in Ukraine we asked about very often, or maybe not only Ukraine, very often it's question about average salary for a particular specialty, area of activities. That's not enough to show only average salary. Tell me median, at least median. So it will be ensured that 50% of staff got at least this or more, and so on. So dispersion or variation. Measures of variation give information on spread of variability over the data values. So here is at the right side shown example of chart when we have two data set. Actually, it's distribution plot of two data set with exactly the same central point. So they have exactly the same average, mode, median, but they are totally different because of different variation. And we have like common assessment criterion like range, the quarter range, variance, standard deviation, coefficient of variation, and so on. So first of all, we turn into quartiles which represent fraction of quarters, or fraction, or especially quarters of our data set. Each quartile represents 25% of our data set. In fact, useful things, it's range. We use range and interquartile range to make the assessment about how widely data is distributed within our data set. Whereas range, it's different between maximum and minimum, and interquartile range, it's a difference between first and third quartile. And here is we can compare it one to other, and it will be usually significant, very different assessment. So as like last pair of scripted statistics or assessment sample characteristics, that's variance, average of square deviation between individual scores and mean. And largest variance, the more variables there is among scores. And standard deviation, square root of variance, and provide representation of variation among scores that's directly comparable to scores. So actually standard deviation have a sign. It could be plus and minus, where variance it's only squared value. Okay. And here is how we can got all these things manually from that previous data set I placed. For sure, it's actually an efficient way to make this calculation manually. Yes, years ago I did it by myself, and it's take time and it's a lot of writing and calculation manually. But what is major benefits that spreadsheet could give for us all this result in a second. So we have few ways. First of all, we can calculate by itself some part of it. We can implement formulas directly, or another way we can use various functions to get all this necessary assessment at a time. And let's move on. Might be better to move slide back. Same way, like I already explained about importance of having multiply central tendency parameters, same reason we have multiply variability parameters. In this case, we compare mean to standard deviation. That's example for the chart I shown before. And here is we have like also presence of outliers or different alignment of data in data set for C case, and you can see how data will be, how standard deviation will be varied depending on of what do we have. What kind that do we have, and in all this case mean are exactly the same. And now we turn into visualization. So how to show all these things? Is it possible to have it at a time? And here is box plot or box and whiskey plot. So it's give for us ability to present a maximum descriptive statistic characteristic of sample within one chart. And when you will study your any kind of scientific publication, when you take scientific article which include his statistical analysis, especially hypothesis testing, almost certainly you will see their box plot chart, because it's very brief and very compact way to tell auditory everything about data set. So we can place median with percentiles as boundary for box in the center, or another approach depending to settings we can use median plus minus standard deviation for central box. Then whiskey with rogue assessment like minimum maximum has to be no more than 1.5 from interquartile range. We can also make assessment about presence of outliers in our data set. Okay. So when you will, that's all following points I want just to make notice. That's when you will refer to statistical documents, statistical textbooks, you will use typically not name of variables and assessment characteristics, but their symbols and labels. And here is we have a few most common, like variance squared standard deviation, or population variance, population standard deviation, sample mean, population mean, and so on. That's very common points, labels used in our terms. And if we want to use like spreadsheet application, we have number of function, and we have analysis tool pack which could give for us also descriptive statistic tool. So here is example common function to calculate few of descriptive statistic parameters. Okay, I think now time to get some maybe live show with spreadsheet that I have my some data. So first of all, I want to show for you two approach to present this data. We can see it as nominal, when each observation is some measures obtained from patient, or if we have not patient but we measure some vital characteristics during time, our data turn into continue categorical. I'm sorry, here is we talk about categorical data, and here is we talk about ordinal, or no, we have talk about continuous and discrete data. So same numbers, that's by intention. I did the same numbers, depending to what do we measure. Is it we observe a group of patients, or the only two patients which observed during time for some specific parameters, it should be considered and treated in absolutely different way. Because here is we deal with continuous data set, and here is we deal in fact with categorical nominal data set. Okay, let's stay on nominal data set when we deal with patient, each observation retrieved from different patient, no matter what kind of characteristics, something has to be. First of all, simple visualization. For sure, in case of nominal data, nothing other than like we can use conventional bar chart, or we can even provide visual comparative analysis with two variables at a time within one chart. So here is same way we can visualize our data series with line chart, and it will be the way to compare it visually. So here is the correct things, correct representation for our nominal data. In case if we talk about discrete data set, we have to treat our data set independently, and in this case the only correct way to use like for example scatter plot give for us information, and same way I can like make selection for touched region and visualize second variable. This time, most cases there is no meanings to display those data on one chart. For sure I can, but here it will be better if I have some minimal suspicion it's kind of bill signals. It would be better to show it independently. However, if they have the same scale, we can display it on single data set and got some assessment. As I already said, also we can try to use to insert like specific chart. For example, we can use histogram data, histogram chart on the modern, I'm sorry, here is this one. We can use histogram chart, which give us actually likelihood for normal distribution for numerical data set. Technically, for sure, I can draw it for nominal data set as well, but it will be not fully correct because in my case, each one patient, it's individual. However, we have fine ability to solving like minimal classification task when system try automatically identify some specific classes when our data fit into it, and at least we have number of patients that fit into specific interval. So from here is we can compare with bar chart only one value to another for each patient, nothing more. Here we can make some classification and made assessment about for both group. What exactly do we have and what groups, some data range could be seen for our data. Okay, and let's move into box plot for sure. Move into box plot. That's for our discrete data. Again, I can also calculate box plot. The only question remains is that it makes sense. Does it make sense? Okay. So fine to have data labels give for me. Okay, let's give for me in this case maximum, minimum, central tendency, and interquartile range on one chart. Similar way, actually more, in this case, it's more correct representation to have it for our, again, for discrete data, technically we have this calculation to do, but we have every time to be very careful. Is this analysis, is this visualization make sense? Because, for example, if it's talking about biosignals, and if this biosignal is periodical, so there is no any information from box plot will be after that. If it's become periodical, for example, like ECG. In contrast, box plot very informative for dependent variable if independent is nominal. It gives for us exact characteristics of this sample. Enables. Okay, it will be like if I would calculate all for me necessary descriptive statistic characteristics with, let me just show for you this. If I want to obtain numerical assessment, so I will start with my data analysis. I doesn't have enough time to enter, for sure, okay. For sure I can use like function average to calculate, to calculate mean, and it will be definitely correct. And it's exactly, here is this value in the center, as you can see, mean value. But I will follow more efficient way with descriptive statistic tools, which give for me ability to select a range I want to analyze, my data in columns, labels, I need summary, contents interval, and my output range. Let me present my results here. And here is I'm quickly obtain all necessary characteristics I have for this data set. Similar way I can do in here. Just let me select. Here is the data set. Okay, it's the same result. Let me place the results there. Okay, so question is only, does it have sense? Technically, we got it. Question is, for nominal data, definitely because each one observation is independent and belong to specific patient. So definitely we work with samples which represent each one observation is independent. But in case of discrete data set, it will depend to origin of it, what actually it represents, what kind of data we deal with, which things we observe throughout time. Depending to answer to this, data could be meaningful or useless. Okay, now let's move into continue with working with move to hypothesis testing. And before we'll start with hypothesis testing, let's again make the assumption about what is distribution, frequency distribution. Distribution statistical data sets, population is listing or function showing all possible value interval of data and how often they occur. So here is we have a range of data and how often we have real occurrences inside this given range. And frequency distribution is grouping the data into mutually exclusive categories, showing number of observations in each class. So here is we have how it could be seen and how it could be represented. Idea of distribution and required to define normal distribution as well as other type distribution. So normal various sample distribution used in hypothesis, but normal distribution is most common example of how data would appear if we create frequency histogram where x-axis represent value of scores in distribution and y-axis represent frequency scores, and they must be similar and therefore a group near center of distribution, and some scores will have usually values will be located from center apex or apex distribution. So here is example of normal distribution, frequency visualization of frequency table for normal distribution, and to provide conclusion and have evidence that it's really a data, our data fit normal distribution must fit 68, 95, 99.7.70. So mean 68 of our data must be within 1 square deviation from center, standard deviation, 95 within 2 standard deviation, and almost entirely all data set must fit inside 99.7 must fit inside 3 standard deviation from the center. So that's like maybe complicated, but very precise way to make conclusion that our data fit normal distribution. Main properties of normal distribution form symmetrical shaped curve, 50 scores lie above, 50 below, midpoint distribution curve asymptotic to x-axis and never cross it. Mean, median, mode are located at the midpoint, and all they lie within that 3 standard deviations. So I already spoken, and here is works for both population as well as sample. Okay, so the reason why do we have that population mean symbol in slide before? In reality, it's almost never happens, and we have skewed left to right distribution. So depending to what is greater, smallest, mean or median, we talk about left or right scale distribution. So our real data set almost every time deviate from normality. And so question is only how far it is. So then when we identify at least what is normal distribution, question is what is hypothesis testing. Actually, we use concept of distribution and we use the hypothesis testing definition as a form of statistical inference that uses data from sample to draw conclusion about population parameters or population probability distribution, or sample. So we analyze sample data, we made conclusion based on sample, but we made inference that our conclusion will be also correct to whole population. So if we extract some representatives for clinical trials, and we have to be sure that conclusion we made in this case when we will observe what's happened for this small group of persons or animals, no matter what kind of trials we made. If clinical trials, it's for sure on humans. If it's laboratory trials, it's laboratory experiment, it's for sure with animals. And we have to ensure that when we made conclusion for this group or samples, that will be exactly the same things for population. Alternative definition is that hypothesis testing is an act of statistics, variably the analysis of a test as assumption regarding population parameter. And methodology employed by the analyst depend on nature of data used and the reason for analysis. So here is key point that is already noted in lecture. Kind of analysis depend on nature of data and reason for analysis. So because technically we can calculate everything. With modern computer, we can calculate everything. Okay, so reasoning for inferential statistics. We have population is normally distributed because they are not, it's maybe various ranks must be applied. Samples must be randomly selected and estimate is compared to underlying distribution of the same size sample distribution and determine probability that the sample estimate reflects population parameters. So here is actually and data characteristics match statistical techniques. For example, interval ratio data, we talk in various parametric statistics like time-test statistics, Pearson correlation, ANOVA, regressional analysis, when nominal, ordinal, or categorical data, we use difference of proportion, chi-square, and related measures of association. That's, again, this slide significantly important because it's actually spoken about how easily it is to made to dump and made fraud with statistical analysis. Just create a non-representative sample, just fit sample to your result. Okay, and you will have that result you want, but not that things would happen in reality. Unfortunately, it happens even in science. Because there is too much dishonest person modern time. Okay, let's move into process, how we have conduct hypothesis testing process. So first of all, we have to overview our data. Usually it's during experimental planning stage. We have to make the assumption about what kind of data we will measure, which type it will be, what is type of our variables that's involved in our analysis. So with looking at data, we have made decision about a statistical general model. And then we have to decide and create new and alternative hypotheses. So here is also a critical point. We create our assumption even very often just after we collect data. Moreover, very often we create our assumption even before we starting our experiment. We made a decision about expectation, what kind of results we want to expect, what kind of proof, if we want to prove something. So here is goal of our hypothesis testing process. And when we already got data, we turn our decision to our assumption into new and alternative hypothesis. That's two statements, which is our versus another, completely opposite in how they sound, and they also have to explain the relationship between statistical parameters and our real-world experiment. Okay, then third point, we look into that and decide about applied statistic tests, like parametrical, not parametrical typically, and depending of kind of analysis, it could be even more points to view about. And then we compute the statistical test as well as significance value. So we compare its so-called alpha level, which has to be 5% or less. In modern research, it's even fraction of percent, and then made decision about that we can accept or reject null hypothesis, like in case of p-value less than alpha, so we have significant result. We made decision about accepting and rejecting null hypothesis. Also, in opposite situation, when p-value greater than alpha, we are failed to reject null hypothesis. So here is important also to admit that it does not mean that we accept alternative in this case. It means that there is no enough evidence to provide conclusion. So same situation, we are not sure, not about null, not about alternative. We are not sure accept or reject it. Accept null and for alternative or so. And it's actually things which is not very, actually it's extremely not liked by researchers, but it happens quite often that we does not have enough evidence. It's a reality. Okay, more detailed let's expand the stage 3, look at data that cite a proprietary statistical test. Because this box, it's extremely complicated by itself. So we have to choose between what we deal with categorical continuous variables. So we compare proportion in groups, or continuous data we compare means or medians in groups. How much, for case of proportion, we have to just decide 2 or more groups, and we usually use chi-squared test, or for example, various tables of likelihood also. For continuous data, we compare means or medians in groups, and depending how many groups do we have, 2 or more, we have to use, again, the question is normal or abnormal distribution do we have for our sample preparation data set. So then we have to use parametric statistics like a normal t-test for 2 groups, or ANOVA analysis of variance for 3 or more. Or in case of abnormal distribution, we have to use Wilcoxon, Kruskal-Wiles test, and much others. So in fact, number of statistical hypothesis testing parameters are already developed, and it's actually one of the hardest questions to make correct choice which one. All the things I show, it's only example, it's not complete guide. Complete guide given in various statistical textbooks, and simplified version presented here. Simplified version presented here in this table. Here is, like, I'm sorry, is it? Oh, sorry. It's like we have 4 classes. In practical class material, I provide even extended version of this table with 6 classes of task. So left column, let me explain what do you see here. At left side, you have practical representation of your problem, what actually could be happened and observed in reality. Like we compare control experimental samples. Like we want to compare usage of 2 different medicine or 2 different treatment methodologies for the same illness and so on. So a statistical viewpoint is compared to independent sample means, or preparation, depending to what kind of data we have. Other situation, particularly if we have samples before and after experiments, so we want to prove that taking this medicine makes significant change in particular vital parameters. So we measure before and after taking medicine our patient, same group of patients, so statistically it's comparing to dependent sample means. And if we want to get proof that when we will take this medicine, our blood pressure will drop below or some specific level, or depending what we actually looking for. So it will be compare population mean to sample mean, and so on. Compare parameter of diffusion in 2 samples. It will be compared to independent sample mean variance. So that's like that we have deviation in the 2 groups. They are taking medicine exactly the same or different, or and so on. Third column spoken about limitation, and every time we are talking about usage of distribution test, is that we have normal distribution or abnormal distribution. And again, every time we expect that our data is quantitative or usually discrete. For all this case, we deal with discrete data set, not nominal, not ordinal. Okay, and right column give for us appropriate test. So when you have you decide to use this table in solving your educational or practical task, you have to move from left to right. So you have to classify your task. You will get a statistical viewpoint that based on this statistic, you have to formulate state of hypothesis, like null average most time. Later you have to check it with statistical test method, but usually null spoken about that parameters does not equal, and alternative that we have significant difference in parameters. And then also you have to explain, okay, the there is no statistical difference in mean. What does it mean in reality? In case if we compare to treatment method or to medicine, means there is no difference which one I will take. Result will be the same. I don't know it will be good or bad, but it will be the same. But if means are different, so probably that there is present difference depending on which medicine I will take. What kind of difference? With which medicine? Okay, next time I have to evaluate this at second hypothesis, when I have to prove that taking this medicine or give for us increase or decrease average in experimental sample. It will be again exactly the same task, but it will be again exactly the same statistical viewpoint, but it will be different statement of hypothesis. And then, okay, conclusion will be depend about test result. Okay, and finally, what I want to say about this table, so every time I noted about the hypothesis testing, every time be careful, because all these methods is represented by some kind of equation. So with data set, equation in Excel, we every time have ability to calculate and obtain some specific result. But if our assumption in our judgment about practical viewpoint of task was wrong, results which we obtain from that specific test will be useless. So it could be absolutely technically correct and does not mean nothing. Or even worse, because you can make conclusion like effect present where there is no evidence of it. There are no evidence of it. Okay, then let's move closely into statement of hypothesis. So as I already said, we have like there is no difference between mean in compared sample, and we have to provide some practical explanation. What does it mean? Has effect, does not has effect, positive, negative, and so on. Alternative. There is difference between means in given sample. Or alternative could sound like a sample in experimental, mean in experimental sample greater than mean in control, or smaller than mean in control. What is actually we are looking for? Proof of difference, or proof that what is important for us? Only enough provide proof that they are not equal, or especially we are interested to know that they are greatest or smallest. Usually when we take in medicine, we have aim to increase, decrease some important clinical parameters. And rejection criteria determine how different parameters and reject must be before the new hypothesis can be rejected. And this rejection criteria based on alpha level are associated with confidence level. And typically it's used the minimum, largest value, which is allowed. It's still 5%. But practically we are looking for smaller critical value, like 1 or even 1/10 of 1. Then how it will be look like if we are looking for that difference I exactly explained, when we are looking not only that our experimental population mean in this case smaller than control sample, control population mean. So here is we have at left-tailed test, and we have rejection criteria at left side of normal curve. In case of two-tailed test, we have to split rejection area by 2 and DR with 2.5%, and it will be only our equal does not equal test, like does population mean equal to our control population mean or does not equal. And all these three cases together, and proper statement of alternative hypothesis for all the three cases. No hypothesis not changed in all this case, and every time will be sound. There is no difference between mean population or sample. And in left-tailed test, control population or sample mean must be less than experimental sample population mean must be less than control. In right-tailed test, it must be greater test, and it's just not equal in two-tailed test. So if we reject null hypothesis, we conclude that there is enough evidence to infer that alternative hypothesis is true. If we fail to reject null hypothesis, we conclude that there is no enough statistical evidence to infer that the alternative hypothesis is true, nor null hypothesis is false at all. That does not mean that we have proven that null hypothesis is true. That it's only that things I told, that there is no enough evidence for conclusion. And that's alpha altogether in type of 1 error or type 2 error. And it's both very bad depending on problem. So here is like simple matrix which I present for us how they could look like this situation when we have to reject or does not need to reject null hypothesis, depending is it we have made correct decision or not. Here is we have two cases for made error. When type 1 error when reject a true null hypothesis, and type 2 errors when we don't reject a false null hypothesis. Oh, we can depict it in very funny way, like shown on this picture, but reality will be every time not as funny as, because it's almost every time it's not such visible. So here is we have two statements about null alternative hypothesis and how look like type 1 and type 2 errors for both this case. Unfortunately, when we deal with number, it's not obvious. And here is we have number of explanation how we can face a null and alternative hypothesis, and it's much more difficult to detect, in fact, type 2 error. So when we fail to reject null hypothesis, like it could happen when difference is so small that it doesn't matter how much, it's very hard to detect difference big enough to care about, but sample size too small to tell you so much, and so on. And here is last one thing that very often happens when we doesn't have enough budget to cover our scientific experiment to create proper sample size. That's reality very bad situation. Okay, about significance I already spoken, so we use 5% as largest level, and depending what do we have in our significance result. If it's less than or equal 5, our result is statistically significant. If our result exceeded, so our result not statistically significant, and we have that chance it's not significant or chance for error. For example, if you talk about like 10% for error, 96% error, 40% for error, that's very bad situation. Okay, and so if we have very low p-value, it's like overwhelming evidence that they're highly significant. But again, we have to be very careful and avoid it also could indicate that our data overfitted, that it could also spoken about that sample were manually shaped in order to get that exact result that researcher want. Okay, so now about technical tool. Usually it's very easy to make all necessary statistical calculation with spreadsheet application, and it's even more easy to use specific solution like R, SPCC, statistical software. They are even easiest to make all this calculation, but they still all preserve the same problem. It's our decision about which method must be used, as well as interpretation of result. So statistical SPCC could select and made emphasis on significant p-value, but nothing more. It still completely depends to researcher any outcome, any conclusion, and okay, what do we have next? With analysis toolpath, we can calculate descriptive statistics, as I already showed, but also we have few tools which give for us Fisher test, test statistics, Z-test. Most of these tests related to parameters, parametrical analysis, and useful only for our data which for quantitative data and discrete data set, and will not work for nominal data set. Okay. Here is example how we can make this calculation. For example, here is like very simple things. We want to we have measures of blood parameters like hemoglobin erythrocytes, simplest blood test, and we want to make decision about does blood parameters depend to gender or not? Is it they are different for men and women? So for sure we have to compare hemoglobin to hemoglobin, and it will be compare control experimental sample. When I go back to the table I show for you, statistically it will be spoken about like null hypothesis, there is no difference between sample independent sample mean. Alternatives, there is present statistical difference in sample means for independent samples. And practical things for null hypothesis, like if null means in sample means that they are like the would parameters not depend to gender, and if present such significant difference for alternative hypothesis, so yes, for sure blood parameters depend to gender. So if you again turn back into that analysis, you see that you will need first of all make decision about distribution type, and simplest case it calculates skewness, kurtosis, and compare this to some table of critical, and for this case I just only can give for you notice they are fall into necessary range, and we have normal data distributed there. So we have to make variance test and then test statistic for test statistics. So actually variance test given for us, as you can see, both test statistics and variance test have very similar interface into data analysis toolpath. We have to provide our variables for analysis. We can choose only alpha level and where we want to provide the output. So very primitive, but all things it's actually behind result. And here as we have it, we have like calculation for Fisher test where we compare variances, and we have to analyze data in such way that a sample with greatest variance must be treated as first, where samples with smallest variance are second, and it's opposite for test statistics. For example, it's very important that it's actually that's also fine to remember that's no matter how your data presented to you, that we are only use descriptive statistic for judgment and for decision about what we have to do next. And here is what do we obtain. So Fisher test and critical value. Null hypothesis for Fisher test spoken that variance is statistically equal. Alternative variances does not equal. So F less than F critical. We should accept we should accept null hypothesis that variance is statistically equal. But look at p-value, 0.44 means we have 44% expectation of our statement is not true. So actually there is no answer. That things I shown at the beginning. We have to report our data, we have to report the findings, we have to report p, and nothing more. We can't not accept null, not reject it, not accept alternative. Anyway, I try to continue with the test and assuming equal variance this time. So what do I have? That this time t-test used to compare means, and I have test statistic which is 4.0, and t critical to tail it because I'm working only equal does not equal. Test statistics significantly greater than t critical, so in fact I have to reject null hypothesis in favor of alternative. Let's check p statistic to tail it significance. It's like 3.0 after decimal Dot means we have overwhelming evidence we are true. We are true. So here is, in this case, we're absolutely correct to say that we have to reject null hypothesis in favor of alternative, which is spoken that there is present statistically significant difference for our data set, and so we have like good parameters depend to gender. And let's say back to my example, and I will make the same attempt to, like, I want to get make some comparison between our nominal data set. So I have to make like, okay, I made decision like, is it there present? Such as we have two independent group. Definitely. I want to have to compare, is it sample means statistically equal or does not equal. Just I does not have nothing to explain practically because I don't know what this data spoken about. So I just know that we have nominal independent variable x, nominal x. Observation, non-nominal observation is discrete in this case for sure. Only independent variable is nominal. And so our observation is discrete. So first of all, I have to quick way to get descriptive statistic again. And even no need to select. Okay, this is the same data. My output range have to be, sorry, here it is. Okay, so I given what is most interesting for me, it's skewness and kurtosis. This for value, which could give for me information about is it distribution type is normal and don't normal. So I will not bring for you right now that critical table, so you can take it from statistical textbooks. I will be given on practices, but I just tell you that's only one value here is now dangerous for our like for this given sample size, which is 41, only one exceed normality. But in this case, in even parametric of statistical criteria, it's have relatively enough probability to be stable for small deviation from normality, and at least group A fall into distribution, and within group B only one parameters not fitted, so we still can use parametrical criteria. So as in previous case I showed on slides, I will start with, I will continue also with Fisher test for sampling variances. So where is we have greatest variance? It's for sure a second distribution. It's have to be treated as variable 1 in this case, second sample. And the similar way, then we use first one. Alpha is 5, we have labels I have included, and output range have to be like that. Okay, so here is we have our result, Fisher test, greatest, then F critical. And we have our p-value is significant. So Fisher test greater than F critical, that's we have to spoken, that's our variances statistically does not equal. So for sure they look like significantly different. And here is we have 1% probability of error, so it's good evidence, very good evidence. Okay, so let's move with test statistics, assuming unequal variance. Good. And this time our where is greatest mean? Also, greatest mean we have under group A, and this time group A have to be fast. So again, order of sample, visible order of sample does not matter for analysis. Only value of descriptive statistic parameters matters. We have labels. Output range, let's say here. So again, we have test statistics given 2.6 and the critical 1.9 to tail it, and our so here is this volume. Good, what I am analyze, and also here is we have this volume. So I compare the statistics to the critical, and I use significance as assessment of how strong evidence is. So it's significantly less alpha level. Again, my conclusion is true. So I have to this time reject also null hypothesis in favor to alternative. And the same things we have here. So actually, those all things I have to talk you about introduction to hypothesis testing for today. Thank you for your attention, and we will continue next time with a question which is related to correlation, regressional analysis, and so on. Goodbye and have a nice day.